Hi guys, this is USACO 2019 February Contest Bronze Edition, and today I'm doing problem 3, measuring traffic. So let's start reading it. So there's a highway next to Farmer John's farm, and there's recently been a dramatic increase in traffic, so he wants to measure the flow of traffic on the highway with sensors. But Farmer John trips and he drops his box of sensors into some milk, and they're broken. Not good. Uh, okay, so instead of telling us the actual flow of traffic as a number, how it's supposed to, it gives us a possible range. So the actual flow of traffic for that section could be anywhere between the range it gives us, right? So his highway is n miles long, and traffic only goes in one direction, from mile 1 to mile n. And he installs a sensor on each mile of the highway. And there's 3 scenarios for each mile. There could be an on-ramp, an off-ramp, or none, right? If there's an on-ramp, that means traffic is increasing after that sensor or after that section. If there's an off-ramp, that means traffic is leaving. Okay. And they want us to output the possible ranges of the traffic before mile 1 and after mile n. Okay. So let's just look at the sample input they give us. So 4 lines, right? Because n is 4, and each one is it sorted? Yeah, so mile 1, 2, 3, 4. Okay. So first mile there's an on-ramp, and then it's just straight highway for 2 miles, and there's an off-ramp. So right away, if we look at these middle 2 lines, the first one is telling us it's between 10 and 14, and the second one is telling us it's between 11 and 15. Well, the actual rate of traffic won't change. So it can't be 15 and it can't be 10 because 10 doesn't work with both of those ranges and neither does 15. So we know that the actual range in those middle 2 miles is 11 and 14. And then it tells us that exactly 1 unit of traffic gets on in the first mile. So that means before the first mile, there was between 10 and 13. Right? Because after it is 11 and 14, we can just subtract 1 from each and we get 10 and 13, which is right. And then in the last mile, between 2 and 3 units of traffic leave. Alright, well then we'll just subtract the maximum amount of traffic that leaves from the minimum amount of traffic that there was. Right, so in our case, it was between 11 and 14, right? So then we'll subtract the 3 from 11 and subtract the 2 from 14, which is good, which gives us 8 and 12. And that makes sense because we want to give the most, like, the possible range, right? So if we know that it could be 3 units of traffic leaving, we want to include that. So we're going to subtract the bigger amount of traffic leaving in order to give us the most wide range of values possible. So we're going to subtract the 2 from the 14 and the 3 from the 11. So I'm going to draw a picture to help us visualize that. So if we have our traffic here, or our highway here, right, and we have 4 miles, and we have an on-ramp here, and then we have an off-ramp here, right? So I'll just write down the sensors they give us. So this is 1 and 1, 10 and 14, right? 11 and 15, and 2 and 3. So right here, this tells us already that the actual amount of traffic is between 11 and 14, because it can't be 15, because 15 is not within this first range, right? And it can't be 10 either. So since 1 unit of traffic is going on, that means before this ramp, there was 10 and between 10 and 13 units of traffic, right? We subtracted 1 from each. And then after the ramp, since let's say 3 units leave, right? Then we're gonna subtract 3 from both of these. That gives us 8 and 12, right? But it could also be 2. So then that gives us 9 and, wait, this one should be 8 and 11. And if we subtract 2, that gives us 9 and 12. So it could be either of those two, and we want to take the range. So we're going to take 8 and 12, which is the same as subtracting the 3 from the smaller one and subtracting the 2 from the bigger one. Okay, so based on that principle, we should be able to just run a loop for each mile in the highway and calculate our possible ranges from there. But we're going to need to calculate the range before and the range after. So for the ranges before the first ramp, we're going to have to go backwards. Because if we know, like let's say we know the amount in the middle, right? Like in the input problem, we need to know that before we know how much traffic went on to calculate the traffic before, right? Because this first mile is only giving us a difference or a change, but we don't know what is changing from. So that's why we need to go backwards. So backwards for the range before mile 1. And then if we're trying to find the range after mile n, then we can just go forwards. Right, for the range after mile n. Because if we just know the amount that leaves, we don't, if we go backwards, we won't know like how much traffic there is before the ramp, right? So just to give a concrete example, they tell us that between 2 and 3 units of traffic leave, but we need to know how much there was before they leave to calculate how much there was after they leave, right? So with that in mind, I'm going to start coding it up, and then I'll revisit the drawing and stuff as we go along. So I'm going to be using Python for this, just to stick with continuity, because that's what we did for problems 1 and 2. Okay, so traffic.in, I'm going to copy this input real quick, if you'll let me. There we go. And I'm just going to do my input. And then we want to make sure we turn our input into integers. Okay, and then for our data, right, I'm just going to make a big array, and it's going to be a nested, or an array and an array, so a 2D array. And I'm going to turn each of these lines into a list. And yeah, I'm going to turn each of these lines into a list and just put that in a big array. So we can do this with a little bit of help from Python. So I'm just going to call this data, and this will be x dot split for x in dot read dot strip dot split at every new line. So what this is doing is taking all of the data after that we haven't read, right? So these lines 2 to 5, splitting it at every new line, and then taking each one of those and splitting it again. So just to make sure, I'm going to print data, and as you can see, that's what we wanted. And don't worry if they're not integers yet, we can deal with that later. So we want the before and the after. And I'm just going to give a wide range for both just to start, and then we can work our way down and get more precise as we go. I think 9,000 is enough, or 99,000. Okay. And then let's just start with one of them. I'll start with the before. So like I said, if we want to calculate the ranges before, we need to move backwards. All right, so I'm going to run a for loop for, I'll call it sensor in data, and then this is just moving backwards, right? All right, so we have three cases, right? If it's a on ramp, a off ramp, or neither. So we'll say if sensor 0 is none, then we'll do something. I'll worry about that later. Else if sensor, I just realized you don't need parentheses for Python, but actually I'll get rid of it. Okay, and then we'll have could do an else, but I'm just going to do this so you can see what it's actually checking. So if it's an off ramp, then we'll do something. Okay, so first, if it's not an off ramp or not an on ramp, then it gives us a range, right? So we want to take, so if it gives us a range, let's say in the middle, right? We had 10 and 14 and 11 and 15. Let's say we were moving backwards and we were already at 11 and 15. That's our current range of values, right? Well, 10, oh shoot, 14 is smaller than 15, right? So we know that the maximum has to be 14. And 10 is smaller than 11, so that doesn't really do anything because it could be 10, it could still be 11, right? So, actually, no, yeah, it can't be 10 because we know that the smallest is 11, right? Yeah, okay, yeah, because it tells us all the possible ranges for that mile. Let me just double check. Farmers, yeah. Okay, yeah, no less than 7, no greater than 13. So if we already know it's no less than 11, then it can't be 10, right? So as we're moving backwards, we can say that the first one in before is, we want to take the maximum one, right? So the max of int sensor 1 and the before 0, right? And sensor 1 is because the first line in sensor is just the on, off, or none. And then before 1, so this is the upper range, we want to take the minimum of sensor 2 and before 1. And then that's good for the highway sections. So what if it was an on-ramp? Then we'll just subtract, right? So we'll say before 0 minus equals 2. We want to subtract the big one. So we want to subtract the upper range of the ramp from the lower range of the highway before, because we want the biggest range possible. So sensor 2 is the upper range, and before 0 is the lower range of the highway. Then we're going to subtract the lower range of the ramp from the upper range of the highway. Right? And then just like precaution, right, we don't want any negative values. So if we ever happen to have a value less than 0, right, then we're just gonna make it 0. And then same thing for the off ramps, we're just gonna add instead of subtract. So we're gonna add the big one and subtract the small one. Okay, this should be good for the range of values before n. And we just have to do the same thing for the range of values after n, but we're going to flip everything. So we're going to move forwards or normally through the data instead of moving backwards. And we're gonna add at every on-ramp and we're gonna subtract at every off-ramp. So I'm just gonna copy paste this here, and then we don't need this anymore. So if it's none, then we still do the same thing, right? Because we still want the max and the min. But I'm gonna change, we have to change all of these befores to afters. So let's do that real quick. Okay, so now we're done with that. We know that it doesn't matter which way we're moving through the highway. We still want to take the values that are consistent with all of the ranges, right? So that will be the maximum of the lower one and the minimum of the higher ones. So that's fine. And then if the sensor is on, right? So now we're moving normally through the highway. If the sensor is on, then we want to add traffic because that means traffic is coming in, right? So instead of subtracting, we're going to do adding. But because we want the highest range of values, we want to add the smaller one to so let's say, how do I phrase this? We want to add the smaller range of increase to the smaller range of traffic in order to get the biggest actual range after the ramp. So after 0, we're going to be adding sensor 1, and then we're going to add sensor 2 to the second after. Because, all right, let's look through an example here, right? Let's say we had another ramp here, right? And this was between 2 and 3. And then let's say, for example, this ramp, right, was like 1 and 2. So if we add 1 unit of traffic, it could be 3 and 4, right? If we add 2 units of traffic, it could be 4 and 5. And we don't know which one it is, so we want to take the biggest range possible. So that's 3 and 5. And that's just the same thing as adding the smaller one to the lower bound and adding the bigger one, right, to the upper bound. So I hope that makes sense. It's the same thing we were doing before, just reversed, because we're adding now instead of subtracting. And then this is going to be the same thing here. So when it's an off-ramp, traffic is coming off. So we're going to subtract it. And from the lower bound, we want to subtract as little traffic as possible. So actually, no, we want to subtract as much traffic as possible because that will give us the biggest range. So we have to flip these once again. And we have to make sure that it's not 0, right? So if it's less than 0, then we're just going to make it 0. So after all of that, I think we should have all of our work done. So I'm just going to print all of before. That's what the stars and after. So let's test run it with our input. We get an error, equals max, and base must be between What? Oh, I forgot a parentheses. Or I didn't forget one, but it was in the wrong place. Alright, now it should run. And we get 10 and 13, 8 and 12, exactly what we're expecting. So I'm just going to download this as a zip and unzip it real quick. And we're going to submit it and see if it works. Here it is, main.py, and come on. Okay, looking good so far. Alright, yeah, I think that's it. Alright, so that was measuring traffic for USACO 2019 February bronze.